All I do is win, 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 no matter what. Got money on my mind, I can never get it up. And every time I step up in the building, everybody hands go up. And they stay there, and they stay there, and they stay there. Cause all I do is win, win, win. And if you go in, put your hands in the air, you can stay there.
All right, y'all, we are back. So you've probably been asking yourself, when are we going to get the opportunity to go ahead and learn something new? Where here it is, new is for you. So in this case, what we're going to be studying is a continuation of circles. But in our continuation of circles, we're going to be looking at solving for an angle on the outside and also solving for an angle on the circle. And we'll talk about that on the back side. So the very first thing we want to know is that this angle is also called a circumscribed angle. It's on the outside of a circle. We talked about that briefly before in other topics. We're going to look at these two tangents. So you might be saying to yourself, what's a tangent? And you're going to have to go back to your definitions, but if you don't have them at hand, a tangent line is a line that's just going to graze the circle. So right here we can see where it just hits the circle just this one time. It can continue. It doesn't in this case, but it can. The same thing for this tangent line here. Now there are some more rules to the tangent line and we'll talk about those later. So I'm just going to list the two tangent lines here, one being AB and the other one being BC. In order for us to solve for this outside angle here, we need to take some information that's already included in the circle. And that information that we need is going to be some arcs. So notice that this touches here and this touches here, creating an arc of ADC and also creating an arc of AC. So what we're going to do is take this minor arc, and of course we know that it's minor because it is more than 180 degrees, and also take this minor arc of 120, and we're going to do some simple calculations. So here we can see that angles formed by two tangents. The only thing we need to do to go ahead and solve for that angle on the outside is take half of the difference of the two. So we're going to include the major one first, and the reason why is because when we're going to subtract, we're going to start with the larger arc. Larger doesn't mean that it's going to always be a major, but in this example it will be. So in this case, we're going to start off with that 220. And we're just going to fill it in here. Whoa, 240. Sorry, y'all. Look at there, just like in school. And then we're going to subtract this 120 that's located here. And in doing so, we're going to do some quick math. And we know that that's going to be 120 as well. I'm just going to bring this down. And then, of course, half of 120 is going to be 60 degrees. Now, just in case I didn't mention this in the directions inside of your focus or on your Teams page, these notes can be found inside of your focus in the 4th 9 weeks underneath notes. You could do one or two things. You can write it down inside of your journal, or you can print it out and put it into your journal. It doesn't matter, but you are going to need your notes if you're going to, 1, ask for help, 2, get the grade for your journal check at the end of this particular 9 weeks, which I will do. Okay? Thank you so very much. Now, if there are questions, there are none that you can ask me right now because I can't hear you. However, if you do have questions, please make sure that you reach out either via Teams or email to let me know so we can set up a time to answer those. And we're moving right along. The next one we're going to look at is two secants. Two secants. Now, again, you need your definitions, but if you don't have them, you know that your secant line is going to start on the circle and it is going to continue through and on to the outside. And in this case, we see that there are two listed here, 1 and there is the second one. Those are the two. So I'm going to name our two secants, and remember, when we name our line segments, it does not matter the order. So I'm going to call this one CA, and the other one I'm going to call EA. And remember, you can even call it AE, or you can call this one AC. It doesn't matter. All right? So when we look at this, what we're going to notice is that we're going to have a minor arc. I needed to make a correction here. So our minor arc here is going to be 100 degrees. And then we're going to have another minor arc of BD, which is going to be 30. Now notice we are not including this arc, and we are not including this arc. And the reason being for that is because they do not meet inside of those lines. Does everybody see that? So here's a secant line from C to E on the inside of the secant lines, and then of course from B to E, which are also on the inside of those secant lines. So please make sure that we realize what indeed we do have. Now in this case, remember, we're still taking the larger one and subtracting it, and subtracting the smaller one, and the reason that we're going to do that is to make sure that we end up with a positive number. So to solve for this angle out here, we're going to do the same mathematics. We're going to take this arc here, which is 100 degrees, and we're going to subtract this one here, which is going to be 30 degrees. So notice all we're doing is taking the formula and continuing it on. And once we do that quick math, we do end up with 70. And when I multiply by a half, of course, we know that half of 70 is going to be 35. So we know that this angle here is going to be equal to 35 degrees. Now, in our third example on this page, we're going to see that we have a tangent line and we have a secant. So we know that our tangent, just from what we learned above, is going to be where it touches the circle and then it keeps going. So we know that our tangent is going to be BA or AB. Remember, those letters can be interchangeable. And we know that our secant is going to be DA or AD, depending on which one you want to write. It doesn't matter. And again, when we're looking at these, we're going to be looking at the larger arc and subtracting the smaller one. And again, if you notice, this arc here is not included because it is on the outside of that secant line. So we're not including that. We're only looking at those that are on the inside. So what we're going to do is take that larger one, and the larger one, of course, is BD, just as instructed here, 164. And we're going to subtract the smaller one, and the smaller one, of course, is going to be the 70. So once we do the 164 minus the 70, we should all end up with 94. And once we end up with 94, we'll take half of that, which will let us know that our angle, of course, is 47 degrees. Now that we have the basic information for these, the next thing that we're going to do is look down here at the bottom. And here at the bottom, we can see that there is a certain rule. It does not matter whether we have two tangents or two secants or a tangent and a secant. What we're going to do is be able to use the same exact formula. For us to solve for that outside angle, all we need to know is that it's going to be half of the difference of the two. So in this case, since we have half, the only thing we need to do is take the big arc. And remember, when I say big, I mean the bigger one. And then subtract the small one, okay? Just like that. And we are done. Remember, these are the ones that are going to be intercepted, okay? So that's exactly what we're going to do here and here. Now, I have one more thing to show you before we get to our examples. So do like that. Is that what you're saying to yourself? Oh, that's so nice. And you're right, it is. Straight up from my own printer. So the only difference that we're going to do on this particular one here is learn about our chord and a tangent. So remember, we already know what a tangent is. And here it is. BC is our tangent line. All right. And then for our chord, from previous lessons, we should remember that the chord is going to go through the circle and just touch the edge like this. Now we know a very special chord would of course be the diameter. The diameter would be a chord as well. And I believe in your circle notes I asked you to create another chord that was not the diameter, but the diameter would also be a chord. So right here we know that it's going to be an angle that is going to be formed by intersecting, of course, the tangent line with the chord. And this time the angle itself is going to be on, or the vertex of the angle is going to be on the circle. Okay, now this formula is slightly different, but it is fairly easy to solve for. For us to be able to find what they call the tangent chord angle, this angle right here of x, the only thing we need to do is take half of this. This is the one that's going to be intersected. Now remember, if I put my hand over it like this, then this is the only amount that we then need to be concerned about, which is that 148. All we're doing is taking half of that. That is it. So for us to solve for the measure of angle ABC, all we need to do is take half of that 148. And of course, half of 148 will give you 74. So I know that the measurement for this would be 74 degrees, just like that. And that is it. Just that simple. Now remember, every time we do notes, we start off with the basics and then we go ahead and build on from there. So what we're going to do next is several examples to show you actually how to put the rules that we learned into play. All right, so we're going to start off with the first one. Now on your sheet of paper, you should have all of these as well. If you had to redraw them and put them in your notes, you should have them too. So the first thing we want to do is read the instructions, and they clearly tell us that the measure of angle 1 and Rx is what we need to be solving for. So in the very first one, we need to pay some attention. Remember, we talked about making sure that we understand what we have. So this here is going to be what we call our tangent line. Remember, I said it hits the circle and keeps going. And see how this grazes the circle and keeps going. So this is a tangent, and this one right here, of course, is going to be our secant. So remember, our formula in this case is a simple one, and the formula for us to be able to solve for the measure of angle 1 is just going to be half of the big arc minus the small arc. Okay? All right, so first thing we need to know is that this arc here, which is going to be our small arc, is 134. Now, what we need to remember is that this is not included. Why? Is because it's not intersected. So this is not going to be a part of it. But we do need to find out what this is here. Probably should have a highlighter. From here to here. Now, if this is 134 and this is 12, what I do know for certain is that a whole complete circle is 360 degrees. And for me to be able to find out how much this is here, I simply need to subtract these two. That's the 134 plus the 12. And then that should give me my answer for here. Now, when I add these two together, we should come up with 146. And of course, 360 minus 146, we should end up with 214. So I know that this outside angle is going to be 214. Now notice, did this take an extra step? Absolutely yes. Was this an extra step that you could not do? Duh. So now when we find this, all we have to do is fill it in. All right, so we've got angle 1, which is what we're solving for, which is going to be equal to half of the big arc, and the big arc, of course, is going to be 214, minus the small arc, and of course the small arc is going to be 134. Okay. Now, of course, in all that we know, once we do this math, we're going to end up with 80. And of course, half of 80 will then be 40. And just like that, we know that the measurement of angle 1 is equal to 40 degrees. Okay. Now, hopefully that was clear for everybody. And we're going to keep going and look at the next one. Now, if you notice, the next one is going to be solving for angle 1 again. But when we look at this, we can clearly see that angle 1 is located here. With angle 1 being located here, we need to know some information. The first information that we already know is that we're dealing with, again, tangent and tangent. So we're using the same formula, which is that the angle 1 is going to be equal to half of the big arc minus the small arc. Now in this one, we can clearly see that this arc here is 270. But we are yet missing, the other arc that goes from here to here. Now this other arc here, of course, is going to complete the circle. So what we're going to do is the 360 minus the 270. And of course, with that simple mathematics, we know that this arc here is going to be 90 degrees. Now, since we know that, we're going to go ahead and fill this into our formula. For angle 1, we simply are going to put the big arc, which of course is the 270, and we're going to subtract the smaller one, which is 90. Now, of course, this is some numbers that we are very much used to. So we already know that that 270 minus the 90 is going to give us 180. And we just need half of 180. And we all know that half of 180 is simply 90. So we know that the measurement of angle 1 is going to be 90 degrees. Now listen, y'all. Just because we got 90 right here does not always mean that these two answers are going to line up, okay? Now remember when we did our other example where we had a tangent and a tangent, it did not mean that all of the numbers were the same. So go back to the very first example where we had a tangent and a tangent. We had 240, we had 120, and then 60. So please make sure that we have a good understanding of how that works, okay? All right, questions. I'm so sorry. I'm not in class. Sorry, y'all. All right, we're going to move on to the next one, which deals with a tangent and a secant. Tangent, we know this is the tangent line because it grazes the circle. And we know that this is the secant because it cuts all the way through here. Everybody see that? Everybody good? Perfect. So now this is what we're going to do now, y'all. I'm going to cover this up because remember this, come on. Come on, now this is just like in class. Now the bottom part doesn't matter because it is not intersected, okay? It is not included, so it has not been cut off by that. We do not need it. So we're going to use a big arc. We're moving straight to the formula because there's no need to waste in this one. No other information is needed. And just like in class, I would ask that you always start off with your formula so that you know what you are doing. Okay, I think that is one of the things that we forget to do. We get real fast, quick draw McGraw up in this piece and start moving and shaking. And before we know it, we don't have the right answer because we move too quickly. So this should be 72. And then, of course, half of 72 would be 36. So again, we solve for angle 1. So we know that the measurement of angle 1 would be equal to 36 degrees. Okay. Now, hopefully we were able to fly through those, and you might have even been able to do these without, of course, me being involved. Now, on our next one that we're going to do, we have to think about this a little bit more. So again, we're going to be using a tangent line and a secant, tangent, secant. And what we're going to do is we're going to take a look at what they give us. This time we're solving for x, but if you notice that outside angle that we've been solving for all along, well, the answer is already there. Okay, so we're going to start off with our formula, which of course is the outside angle. And we know that the outside angle is going to be equal to half of the big arc minus the small arc. Now, what you might be saying to yourself is, we have no idea what the small arc is. And you're absolutely right. So we're going to do some old school mathematics in this and take this bad boy all the way back. There's going to be 2 ways in which you can solve for this, and you must, from your own algebra skills, set up how you're going to be able to solve for this, all right? So in this case, what we're going to do, that outside angle, we know it is 38. And we know that that's going to be equal to half of the big arc, which we already know is 180, minus the small one, which is going to be x. Now, don't get lost in the sauce and nervous. You can do this. What do we have to do if we want to get rid of a fraction? Remember, to get rid of a fraction, we can multiply by its reciprocal. And the reciprocal in this case would be 2 over 1, or the whole number of 2. But whatever we do to one side, remember, we must do to the other side. These cancel. And then here we're going to have 2 times our 38. And of course, 2 times our 38 should give us 76. 76 over 1 is just 76. And of course, that's going to equal 180 minus x. Now, what we should see in front of us is just going to be a linear equation. We just need to get rid of that 180 to get x by itself. Of course, that's going to be our first step to get it by itself, because even once we do the inverse operation of adding by subtracting that 180, we still have yet another something we must do. Now, that negative number is larger, so what we're going to end up with is a negative 104. And that negative 104 is going to be equal to the negative x. Remember, we're just going to bring that straight down. Now, of course, negative x is not an answer. We must get rid of that negative. And we can do so, of course, by just subtracting. Dividing by negative 1, because a negative and a negative, of course, will give us positive. And we're going to do the same thing over here, which means that our x would then, of course, equal 104. Now, this is the steps to show you how to do this. However, there's a lot of mental math that's included in this that you could probably do on your own without going through all of these steps. And I do realize that, but please make sure for your work's sake that you have something on the paper in which I can follow so that you can get credit for your assignment. Now, all the ones that we have done have been just like the front side, where we've been looking to solve for that outside angle, or that outside angle came into play. Now we're going to be looking to solve for, of course, use this to solve for our tangent chord angle. So our tangent chord angle in this case is 96. So we know that this is going to be 96. We notice that this tangent line here forms what is going to be called a straight straight line. And we know that a straight line, of course, is going to be equal to 180 degrees, and we all remember that from school. What we now need to solve for to be able to solve for this here is going to be our tangent chord angle over here. Bloop, bloop. So simply, we're going to take that 180 and we're going to subtract the 96. Now, there's two ways to do this, and this is just one. So when we subtract our 96, we're going to end up with 84. Remember, the formula to be able to solve for this is going to be that angle, whatever it is, the tangent chord angle. We'll call it TCA. Is going to be equal to half of this, which is x. Okay. In this case, we know that it is going to be 84. Remember, to get x by itself, we simply need to multiply by its reciprocal. And in multiplying by its reciprocal, we know that this is going to give us 168. Now, that's one way to do this. Now, you're saying to yourself, you can do the same thing on the other side. And you're absolutely right. So I'm going to do this a second way. The TCA will be equal to half of our arc. All right, so over here, we don't know what our arc is going to be, but we do know that this is 96. And then we're going to take half of that, and we're going to be looking for the intersected arc. Of course, we'll multiply both sides by 2 to get rid of that. So our intersected arc over here, see, it's just going to be 2 times the 96. And once we get that number, we're going to be able to subtract it from the whole entire circle. And in that case, subtracting it from the whole entire circle, we should get this answer right here. Now, what I would like for you to do is to try this, finish this up, and subtract it from 360, and see if you get the same answer. All right, hopefully you can do that. Now, I have shown you how to do 1, 2, 3, 4. We have worked through 5 examples. I'd like for you to try this one. And I would also like for you to try this one. Okay, now before you get ready to answer the question, I need for you to label everything and then go in to answer it. I think that is fair. Okay, and then we're going to jump to this last one and hope that you are able to stick this through with me. Okay, yeah, let's label it and let's see where we go from there. So they're talking about the diagram. They're talking about first PA as a tangent, and then they're talking about second this PBC as a secant. And they're talking about this drawing on circle O, and this is indeed circle O. They're telling us that ADC is going to be twice the amount of AB. So remember, whenever we're dealing with anything like this, we're going to use variables. Now, you can use just AB, which is fine, but let's go ahead and use the variable for that. And variable, let's say X. It's been one of our tried and true variables. So if this is X here, if they're telling us that this is then twice as much as this, then we know that this is going to be 2x. Okay, hopefully everybody has that. Now remember what our formula is. This is the angle that's on the outside. So we've got the outside angle. And the outside angle is simply going to be half of our big arc minus the small arc. Okay, and hopefully this should go pretty smooth. So the outside angle, of course, is 50. That's angle P. And we know that's going to be half of the big arc, which is 2x. And then, of course, minus x. Now, we can do one or two things at this time, but we'll go in the original order when we're doing inverse. We're going to multiply both sides by the reciprocal of the half, which will give us a cancellation here, and will give us a total of 100 here. Hopefully everybody's good. Nobody's lost in the sauce. Alrighty. So, of course, if we have 2x and we subtract an x, then we are going to have just x, and you are correct. So I know that 100 is going to be the answer for my x, and x indeed is going to be AB. Now, they only asked us for this one, but if they did ask us for ADC, all we would have to do is fill in that 100, which of course will give us 200. If you are to work this formula backwards, you would be able to see that we're able to get exactly that answer of 50. Now, I hope everybody was able to follow along. Now, if you do need assistance, let me know. And if you don't and you're able to do the assignment without any help, then good as well. Thank you for listening, and I hope you enjoy the rest of your day. We'll chat again soon. I am sure of it. Goodbye.